Good morning, everyone, and thank you for joining us today. My name is Davide Mantegna, and I'm a project manager of Bonaparte. Today, we would like to take you through a presentation focused not so much on the production process itself, but how the process is protected, managed through the isolator and machine system. Our idea is to show you that the isolator is not just a simple enclosure, but an integral part of the production system, designed to work in coordination with the machine inside it. Now, I wait just the first slide. Okay, in the modern pharmaceutical environment, especially for the high-potent API application, companies require systems that ensure batch flexibility, continuous operation, and safety levels compliant with the OEB application. Today, the traditional machine inside the isolator concept is replaced to an integrated isolator and machine system designed as one complete and GMP compliant process unit. The isolator is the main GMP compliant process environment where the machine operated during the production, changeover, and cleaning. All the operations are traceable, repeatable, and easy to validate, and drastically reducing the cross-contamination risk and ensuring the operator protection even in OEB 4 and 5 application. The solution that today presented include a capsule filling machine in-cap WIP, WIP, and tablet press machine, the CPR-18 WIP. The machines are designed for operated inside the isolator with a compact layout, optimized mechanism, and component accessible through glove port. Avoid post-design modification. The system integrates the H14 HEPA filter, split butterfly valve for loading the powder, and the deduster with the integrated metal detector and the control lifting system. All subsystems are coordinated to maintain the required containment level and make the validation more easy. Now, with the help of my colleague Lucio, I show you the example of HEPA filter and where the HEPA filter are positioned in our machine. The HEPA filter is positioned here, 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 and here. And the replacement of that filter method is push-push, also designed to maintain the containment and operator safety. Then the split butterfly valve is positioned on the top of machine. Then the deduster with the metal detector and the lifter are not in the scope of that supply, and for the reason today is not available, but you can see that on the slide. Then the washing place WIP system provide an automatic, now we're waiting the other slide. Thank you very much. The washing plate WIP system provide an automatic cycle using spray ball and spray gun with the internal geometries designed to avoid liquid pooling. Drying is done by air through the same process line, and in this way reducing the cleaning time and preventing the containment break. In our machine there are 3 spray balls positioned in that position. This is the first spray ball, this is the second one spray ball, and this is the third one spray ball. And we have 2 spray guns. One is here and the other one is there. The spray gun is positioned in the easy point, in easy access point for the operator. The product transfer is done from RTP port, split butterfly valve, BIBO or continuous liner, ensuring the containment during the process. The system modular is adaptable to specific transferred solution required by the user. The current setup is included an RTP port, positioned in that part of the isolator, and the continuous liner. That the operator could apply in the back part of the isolator. The RTP port ensures the height containment and integrity safety for the operator, and the continuous liner reduces the risk of the power or material release and protect the operator during all the operation and make more easy the cleaning and the maintenance. Regarding the HMI and data integrity, it is very important to show you that we have a single centralized HMI that manages the entire system, isolator parameters, machine parameters, WIP cycle, alarms and trend. The system ensures the data integrity and is full in compliance to CPR-18 part 11, make audit and inspection more easy. Now we can show you a quickly overview of the HMI. From the first page, it's clear that all the process is managed with one HMI. You can find in this page the part for manage the isolator process and for manage the CPR process. Regarding, for example, the isolator process, if I go inside the process page, in that page you can check the fan status and the pressure inside the isolator in Pascal. And one of the most important things of that page is the part of leak test. The leak test is most important because without leak test passed, the isolator doesn't work and the process doesn't start. Now, after that, I can show you the first machine. The first machine that I want to show you is the CPR-18 tablet press machine. In that case, we apply a magnetic because we need to bypass the safety, and the isolator has just one opening window in the front of the isolator. One most important thing is that all the part of the isolator in contact of the machine in contact with product are in stainless steel 316 or in FDA certified food grade plastic. The product comes inside the machine from the butterfly valve, as I showed you before. After that, the product arrives to the feeder station. The feeder station has inside the star with a blade that transports the powder and the product directly inside the die. The turret in this case is the turret 11 punches type B, but is possible is also available other kind of turret as 9 punches D or 4 punches B and plus 4 punches D. Then in the first station there's the charge of the product. There's another station where there's a pre-compression. The main compression is there, is the other station, and the last station is here. Sorry. It's here, and is the ejection station. Each station, each of these 3 stations is equipped by a load cell. The data from the load cell, you can check the data, and the customers on the operator could check the data from the load cell on the HMI. CPR, parameter, reading. Here. This is the page of the HMI where the operator could check the data from the load cell. The operator could check the data in real time, and the data are stored for reporting after the production. One other important thing is regarding the regulation of that machine. That machine, in this case, the regulation are manually. It's here, please. Here. From that wheels. From that wheels, the operator can manage and set the weight of the tablet, can set the height of the pre-compression and the height of the compression. All the data is showing on the first page, in the page of the process of CPR-18. This is the main page of the CPR, the tablet press process. You can see you can set the mode, if automatic or manual. You can set the spin. That machine has the maximum speed at 30 RPM. You can set the number of the tablet, start and stop for the production. And the operator can enable or disable the feeder, set the direction of the feeder, and the speed of the feeder. The maximum speed of the feeder in that case are 35 RPM. These are the positions that I mean before. The position for the dosing group, for the weight of the tablet, the position of pre-compression, and the position for compression, for the main compression. In the other part of the HMI, we can manage the split valve, just for ensure that the split valve are lock or unlock. We can enable the deduster, able or disable the deduster. We can enable or disable the suction pump and the tablet sampling. In the last station of that machine, there's a chute. That chute has 2 ways. One way is for the good tablet, and the other way is for the sampling. The operator can make the sampling directly from the HMI. There is also a sensor here for the presence of the powder. This sensor is also, the operator can also activate the sensor or deactivate the sensor, and if the sensor is on, when the powder is not present inside the feeder group, the machine stops. The operator can set also the time that the operator wants the sensor read. Okay, after that we can start with a small demonstration. Now Lucio set the parameters on the machine, and we can see the production process. As you can see, now the feeder is able, then the powder arrive directly inside the die. In the first station there is a pre-compression. The pre-compression is the utility for the pre-compression is for get off the air from the die. The main compression force for the second station, and finally in the ejection station we can see the tablet that goes out from the chute in the good way. In the machine there is also present an aspiration pump. And as you can see, the system is very compact, and for the operator it's very easy to arrive in all part of the machine. During the process we can check the parameters of the load cell. All the parameters are expressed in kilonewton. Pre-compression parameter, compression parameter, extraction parameter for each punches. We can set also in the same page the target and the maximum force that we want to have on the station that we set, and if we set a maximum force, after that maximum force the machine stops with the alarm. Now we can stop the machine.